All right, so now let's look at the residuals of our VECM model. I'm going to go to the notebook file right here. All right, so if you look at the project, I actually have sample code that you can use. So we want to look at the residuals. We want to know, do they look homoscedastic? Do they show autocorrelation? It should be stationary, so it shouldn't look too crazy. So let's plot it. If we look at our residuals, remember this is a bivariate time series model. We have two variables. So if I look at the residual, I said reg. I want to look at the model residuals. So now we have two arrays in this. So the one on the left would be x, the residuals of this epsilon xt, and the one on the right will be the residuals of y. So epsilon y comma t right here. So if we want to look at these, well, let's plot them out. So this is an array. You can't just do dot plot because it's a NumPy array. It's not a pandas series. It's not a pandas data frame. So we can't just plot it out. Real quick before we do plot, remember back from one of the previous classes, so I've been back from last semester, but from with an array, if we do the call, and this would just be everything. So if we want to look at the one on the left, this would be it's rows comma column. So if we want all rows, column would be all rows, and we just want column 0. This would give us all the residuals for x. Then if we change it from 1, because remember the index starts at 0 for Python. If we go to 1, now this is all of the residuals for y. All right, so let's in the sample code we have it VECM timestamp because it's a little bit different for this. So we're going to set this equal to be the timestamp. DF timestamp. Before I even do that, let's just look at the DF timestamp. This is the time or the date for each of our values. And the reason why we do index location and the number of lags plus 1 is because our model, our predicted values for our model has a lag to it. So if we have a lag of 1, then this is not going to start. Our predicted values and our residuals aren't going to start at October 14th if we have a lag of 1. They're going to start on the 15th. Or if we had a lag of say 5, then our residuals and predicted values and fitted values aren't going to start on the 14th. They're going to start 5 days after the fact. So let's do index location. Don't forget that has to be the brackets. Let's just say 2 and everything afterwards. So this would be the 16th and onward. And this will be our x value. So let's do POT.scatter. And let's look at the residuals for our x. So let's do VECM.resid for the residuals. We want all the rows in the first column. And let's make it red. So color equal red. Let's make it 50% transparent. So remember alpha is transparency. And let's label it x. So we're going to label x. We know what x is. We'll look at it. Oh, VECM's not defined. Oh, it says it's not VECM. I named it MDL for model. So there we go. So it worked. And this looks pretty stationary. It doesn't look looks homoscedastic and doesn't look like there's autocorrelation, looks pretty consistent. We have this value here, but this could be partly because Bitcoin at the time was relatively new and there could have just been errors with it. Maybe it's just an extreme value. So let's do this again, but this time, let me get rid of this. Let's do it again, but plot the residuals for Y, which would be log Bitcoin. Let's make it blue. And we don't want the first column. We want the second. So now we plot them on top of each other. So this would be Bitcoin. This would have been stock to flow. So perhaps this was just a problem with it could be a problem with data. It could be may not even be a problem, but that's something that you may want to look into. But ignoring that, it looks pretty good. It doesn't really seem, it seems homoscedastic. It seems like there's not a lot of autocorrelation. It seems like it could be a good model. So this is this would be part 11. So you can see this is the plot you want to attach, and we want to name it or add a let's add a title. Let's say VECM residuals, and let's plot the y-axis, y label. Let's say residual. If you wanted to add a I don't know if this is going to work or not, but if you wanted to add a yeah, there it is. So if you set epsilon for residual, you just give it the dollar signs, and then you can type in latex notation. And let's say the x label, x-axis is date. So here we have our residuals. If you want to add a legend, you can do pot.legend, and I'll just review. If you just leave it, need to spell right, but if you just leave it blank, it will automatically go by the best fit. So it believes the top right is where it should be. If you wanted to move it around, you say location is equal to, and let's say well, let's actually look at what the options are. Just make sure I'm spelling everything right. For these parameters, you can do loc equal, and you have all the way up to 10. So 0 to 10. So you have 11 different options. Default is best, so we'll just put it wherever it thinks is best. But if you think it belongs somewhere else, then you can change it. But I'll just keep it there because that's what it believes is best. So these are the residuals, and it looks stationary. We know that it is. So this is part 11. The next video we'll plot out our fitted values, and then we'll maybe look at possibly maybe this has overfit the model or the values.